TCR is a programming approach invented at a Kent Beck workshop at the suggestion of Oddmund Stromo. TCR stands for Test, Commit, or Revert, and it describes the workflow. You start with tests all green, and then you're either going to make a move to write new code, test and or production, or you're going to make a refactoring. Either way, you make your move and run the tests. If they run red, you revert and try again. If they're green, you commit, and now you have a new version that works. We're going to take an example Kent Beck used a few weeks ago, computing the substring of a pair of strings. We'll take the left, the right, and the start and stop indexes. So here's some examples. Each one uses ABC and DEF as the strings to look at. The first one looks at 4, 4. This range doesn't cover anything, so it returns an empty string. The second one takes 0, 6, which is the whole string, ABCDEF. The third one is probably the most interesting. It starts after the first character A and ends after the fourth character D, so it takes the string BCD. Now our solution has a constraint. We don't want to build the left plus right strings unless that's the answer. A simple implementation would concatenate the two strings and use the appropriate indexes, but that causes performance problems and creates garbage. So imagine the two strings are very huge. We concatenate 1,000,000 characters on the left string and 1,000,000 characters on the right string. Maybe we just want 2 or 3 characters in the middle, and we've wasted all that time going along those strings. Then we throw away that giant string we just built. So in doing this sort of exercise, I find it helpful to think a little differently about strings. You may be used to thinking of them as an array. The slot 0 has the A, 1 has the B, and so on. But I learned a different technique from a book called The Art of Text Editing by Craig Finseth. He said, how about taking those indexes and using them to index the gaps? So gap 0 is before the letter A, gap 1 is between the letters A and B, and so on to where gap 6 is the whole string. You can also think of it as the number of characters to the left of the index. So let's do some code. Kent did his example in Python, but I wanted to try it in Java because I wanted to play with a new little tool. This is the limited whip plugin, and they've put in a TCR mode. So let's enable that. It will notify us when it reverts, and when the test passes, it'll commit with the last commit message. So far, all I've done is a basic commit with just an empty test in it. Let's demonstrate the plugin. We'll do assert equals. If you want 2 and 2, we expect that to work. 2 should equal 2. So let's run the test. And down here we can see the test passes. Suppose we try a different one. We try to run 3. Let's run the tests. We expect this to fail. Notice down here, limited whip, changeless was reverted. And our code went back to 2, 2. And that's the way this tool works. Whenever the tests run red, it reverts the code, going back to the last working version. And we'll just make sure we're still there. Okay. Let's tackle our real problem. For the test we're going to do, let's just start with an easy one. Let's do select everything. So we're using that ABCDEF again. And we'll call it substring ABCDEF. We want to take index 0 through 6. The substring method doesn't yet exist, so let's just create it. We'll just leave it in here for now. Get us moving forward. Okay, now in regular TDD, you might try and make the test fail first. But in this case, we're just going to try and make it pass. So we run those things. Tests are green. Okay, and it committed. Now, if you remember a constraint, we said we didn't really want the solution to be like this. And that's fine. This is just a step on the way. I think getting rid of that is an optimization, not a fundamental thing. And I think it's going to be pretty easy to get this thing right. So we'll make another chest. We'll select just part, A, B, C, D, E, F. We'll use the example there, 1 through 4. Okay, and if you remember, we said that should be BCD. If I just run this, it's going to fail because we don't do anything about these indexes. But let's go ahead and put those in place. Begin index, end index. Okay, and I think this should work. We'll run it. And it does. So we've solved the basics of this problem now. If you request a substring and you give it the indexes, then it's all just fine. All right. And so the solution is not perfect from a performance point of view. Let's deal with that. So one thing I want to do is start straining the constraints. So the substring method from Java isn't very flexible. It only really wants values in the range 0 through the length of the total string. Okay. Nothing enforces that, but let's assume we need to enforce that. And we want to shift to something that only pulls out the pieces we care about. So really, we would have preferred to select just the BC and append it to the D, not append the whole string together. So let's make another test. Let's check what happens if the left index is too small. It should be clamped at 0. So if we went from -1 to 4, okay, we expect the -1 to be clamped up to 0, and then we'd have A, B, C, D coming back. I honestly don't remember JavaScript specification well enough to know if this is even going to work. Boom, no, it didn't. Okay, so it tells us the substring method is just not that careful about things, which is fine. We'll deal with it. But notice it reverted my test as well, and you can turn that off in this tool, the limited whip plugin. Left side is clamped at 0. We expected A, B, C, D with -1 to 4. Okay, and let's do, we'll say if A is less than 0, return 0, else return A. Let's run them again. Okay, so we've successfully clamped that end. And as you might guess, we're going to do the same thing on the other end. Right end is clamped at string length. We'll take 1. Our string has 6, so we'll take 10. All right, and we expect B, C, D, E, F. Okay. Now, notice we're going to use this pattern of actually fixing it before we run it. So if B is greater than the length of the total string, so that's first plus second dot length. If it's greater, then B is going to equal first plus second dot length. Else it's just B. Okay, so we've successfully added this little bit of error checking, I guess you could call it, functionality. It's part of the constraints on how our system interprets these numbers. But there's an opportunity for some refactoring. Okay, so this is redundant. All right, very simple refactoring. Okay, the other one I noticed is we got first plus second a number of times. So let's extract a local variable for that. We can replace all 3 occurrences, and this is the total string. Again, let's run. Okay, so what else can go wrong? What else can we do refactoring wise? Well, I see this one twice as well. Let's pull it out too. We'll take both occurrences and total length. Okay. A is simpler because 0 is always there on the left. All right, what else can go wrong? Well, I can see several cases. One is the A index is bigger than the whole string. Another one is the B index is negative. Another one is that A is bigger than B. So A is the first index position, B is the second, but if they're swapped, then we should have an empty string. All right, and let's start with that one. It teaches us a little something extra. Okay. So when first index is bigger than second, return empty string. Okay, so we expect an empty string, ABC. First index is bigger. Let's make this 4 and 3. Okay, so make this 4 and 3. We've clamped A to a valid range. We clamp B to a valid range, but we don't know if the substring method does this properly or not. So I'm just going to run this. We'll just run them all. Does not. Okay, let's try again. Let's say empty string when indexes cross. Empty string, index 4, index 3. Okay, and now we can guard against that. If A is greater than B, return an empty string. So we'll just put a guard in the front of the whole thing. All right, works properly. All right, let's deal with the other bit of clamping. I guess I'm going to say left start index is clamped at string length. Okay, so if my start index, I've got the 6, what happens if I say 7? Now this is bigger, that's a problem already, so let's make them match. And I'd really like to get an empty string back. Again, I don't think that the code I have is going to do that. So A is restricted on the 0 side, but if it's bigger than the total string length, it's not going to work. Okay, so let's say if A is greater than the total string length. Now I see I lost the refactoring too. If A is greater than the total string length, we're going to return the total string length. Otherwise, we'll just leave it alone. I think this will pass. Okay, but again, let's do some refactoring here. So this, we'll get all of these is the total string length. Okay, and that's a straightforward tool refactoring. I don't anticipate any trouble. Let's do a little more creative ones. Let's move the A calculations together. Let's see, is that so that's a move line, okay? Move one more. Okay, so get these right. Okay, so we calculate the total string. Now let's do the stuff. Okay. so we've got our first check. We have some setup. We have the A's and this. I mean, our method's getting a little long, but I think we can do the B's first. Okay, and then left end clamped at 0. I think that really should be start index. It's clamped at 0. And that sort of tells me this name is better off as start, maybe. Rename is Shift F6. We'll call this start. And similarly, we'll call this stop. And let's lock it in. And it commits. Okay. We've clamped the start index. We've clamped the stop index. Just make sure that locks in. And let's make sure this stop index is clamped on the low side. And we expect an empty string. Now, unfortunately, I can't isolate the stop index too well with this. But that's okay. Let's see if it works. We got to add something here for that. So stop is, if the stop is less than 0, return 0. Otherwise, return stop. Okay, let's move these lines around so we can see there's a pattern here. Let's take advantage of it. So what I'd like to do is extract this out and reuse it, but I'm using this start one twice, so it makes things a little worse. So let's make a new variable from this. If I said effective start is that. And then I want to use that. And so now I want to use effective start instead of that. Kind of a big change, but let's see if it works. All right. Okay, so now I can do the same thing here. Effective stop is that. And use it down here. I'm pushing them to become more similar so that I can extract a method out. Okay, I'm going to call this clamp, because I'm trying to clamp down the limits of this thing, and we'll just say index and a length. We'll do the refactor. And let's make sure it worked. Okay, so now this is looking nice. I've got the effective start, effective stop. They're based on that, the limits of this thing. Okay, so now I have this thing working with lots of boundary tests, but it uses that first plus second like we have in line 44 here. We want to get rid of that. I'm going to do something where I do things somewhat in parallel then. So I'm going to keep running this test while I do it, and then make sure that the pieces I add don't create any trouble. Okay, so my focus is no longer going to be on these tests per se. I'm going to try and get the pieces in place so I can, in the end, I'm going to return a piece of this left substring plus a piece of the right substring. Okay, and so let's calculate some of these things. So let's just start with the left. The piece I want from the left, I'm going to start at the start index, but I don't want to go any bigger than the maximum of that first string, the substring. Okay, so let's talk about left start. I'm just making up a new field here, and I'm saying left start should be clamped to. We're going to clamp the start index, but instead of total string length, we're going to take first dot length. Okay, so we think that's a valid reference, and it shouldn't hurt anything to calculate it. We trust our clamp method. We're just talking about things that are legal to talk about. We have a little dead code though, so I'm sort of implementing this algorithm in parallel with what's here. Okay, and so let's take the left piece. The left piece, we're going to take the first string, and we'll take the substring. From left start. Where's he going to go? Well, he's going to have to go to left end. We don't know what left end is yet. Let's figure that one out. The left end, this time we're working with that second index. So we're saying the left end is we're gonna take the stop index, and again we're gonna limit it to the length of the first string. Okay, and then we're going to calculate the left-hand piece. Okay, now if I've messed things up, I might explode in the middle, but I'm hopeful I don't. Okay, so I think I have a left-hand piece that's the same as the start of the string. Okay, if I really wanted to be careful, I could extract this out and check that before I come back. So let's do that. Okay, I'm not going to care too much about the name, but I'm just going to make, if not, let's call it, all right, I'm going to check that it really is. So let's extract it out. This is the result. Okay, we'll take the total string, and my claim at this point, if I've done the left piece correctly, I should see that result dot starts with, it should start with a left piece. Okay, and I think I can just use the Java assert. I really don't use that much. Usually I'm using the JUnit one, but we'll just put this in here for now. Okay, and hopefully the pieces are right. Okay, so now we know that this piece is there. It makes me feel good. And then we can do something very similar for the right-hand side. I'll take a little bigger step here. Okay, this is the right start. We're going to clamp from start okay, the right part, the start, it's going to have to be the start minus the first dot length. So my claim is, if we have an index that starts after the length of the first substring, then we're going to shrink that part off and restrict it properly. The right end, we're going to do the same thing. We're going to take the stop index and decrease it so that it's in the range of the second string. So we're pulling that first string out, the length of that out. All right, and then I'm saying the right piece should be second substring. We want the right start and the right end. All right, let's make sure it doesn't blow up first. If I've done something to generate an exception, yeah, there it is. All the tests blew up. Strings out of range. So let's go a little slower. Okay, the right start. We're going to clamp from the start position. Start minus first dot length. And so for an example of this, we've got A, B, C, D, E, F. Let's start at index 2 and go through index 4. Okay, so we should get CD. If we are talking about what are we going to pull out from the DEF, our start has to be adjusted. So our start is 4, but we really have to pull off the first 3 characters. Okay, so I think that's okay. All right, now the right stop. We're going to clamp our stop index. And I think it's the same argument. Okay, I'm not making my argument well, I think. So the first one we said 2, but really it really should be 0. So clamping 2 minus 3 is minus 1, and it should come up as 0. The right stop, we're clamping the stop 1 to the original stop minus the first dot length to get rid of those. Again, I think that's pretty safe. And so my mistake must have been in this right piece. We want to take the second substring. We want to do the right start and the right stop. So there's something wrong with my clamping. There's something wrong with the clamping. So if we take this one, the start minus first length, 2 minus 3, we get a minus 1 there. So we pass in a minus 1. That's fine. The start 2. Okay, so there's something wrong with my clamping, and I think it's really the start here. My length, I really need to be working on the second, the length of the second piece. So I think the start index really is the one that I need to be less than length. That needs to subtract the length. Okay, if I take index minus first length and then I do second dot length. And then by similar argument, stop minus first length and second dot length. Okay, I think that should be safer. Let's get that locked in. All right, now let's try the right piece. We're going to take the second substring. We're going to take the right start and the right stop. And hopefully not blow up. Yay. Okay. And now I can make another assert. I'm going to assert result that ends with the right piece. Okay, so now it starts with the left piece, it ends with the right piece. It's not every assertion. I guess if I knew that one more assertion, result.length, is the same as left piece.length plus right piece.length, then I wouldn't have to worry that they somehow overlapped each other, because it can't be the same as the total length unless each piece is the right size. Okay, so now we're here. We've got the left piece and the right piece correctly. We would like to try returning that instead. So let's return the left piece plus the right piece. We're not using result anymore. All right. Okay, so now we have two algorithms in place. Let's get rid of one. Since we don't care about, we know the result is right, and we don't need these assertions anymore. Let's clean up that much. Okay, I don't need this comment. I'm not using effective start and effective stop anymore. Not using total string length anymore. And I'm not using the total string anymore. All right, make sure that's still good. Okay. I do see duplication here. Let's clean this up. Replace all four with first length. And we got second length occurring a few times. All right, let's hope it works. Okay, so we're in much better shape. Now, I don't know what to call this piece, but I suspect I can make a method of it. Oh, first length and left piece. Okay, well, I was hoping I can make a method out of this one. And I don't even know what to call it at this point. It's get the piece. Let's replace both. Now, first length is the length of the first argument. Second length is the length of the second argument. So I'm pretty sure we can get rid of that. So let's clean up the naming a little bit. First is okay. First length. Let's just say first length equals first dot length. And get rid of this parameter. Refactor should be a change signature. we'll remove this one. This is really any string. Let's rename. Let's check for this. Look like a pure one. So okay. So first length. Let's just call this length. Oops. Length. Stop index and go. Don't need second length anymore. And this first link doesn't really get used till later. So we're left getting the pieces of the solution first. So we'll check that the indexes don't crisscross, in which case it's just an empty string. Otherwise, we'll isolate the left piece by looking at the first string, start and stop. We'll isolate the second piece by looking at the second string, but moving our indexes over by the length of the first string, and then return the two pieces that we get back. And I think this will be a good place to leave it. Now, this substring I left it in the test class. It belongs on another class, but I don't think that changes the essence of the solution. I'm looking at these names a little, index and length. I kind of want to make this a new name. Let's inline this. Oops, we want to remove the variable. Okay. Hopefully that's not too bad. After thinking things over, I thought I'd add a couple more remarks. One is I'm looking at this clamp routine, and this method probably could use max and min. I'm not going to make the changes now, but it's probably worth considering. I might end up liking this better, but it'd be worth playing with. The second thing I realized, I've used a symmetry myself that probably isn't so good. In my tests, I had the first string and the second string be the same length. So if I were going further, I'd play around a little bit there and make sure that that factor doesn't matter. It might show up here where we're using the first length. Since it's the same as the second length, we could get that wrong easily enough. Finally, I wanted to return to this TCR diagram and emphasize again how we went from one version to the next version. We moved forward to write some new tests or production code, usually both. And if the tests failed, like happened a few times, we reverted and try again. Same thing on the refactoring side. Refactoring is supposed to create the same behavior. If it doesn't, tests fail, then again, we revert and we'll try again. If the tests all work, it's all green, we commit, and we've got the new version. And so we have this sort of very symmetric flow between them in a way that makes us work a little harder. I know several times where the test disappeared, and I thought, oh, it would be nice if that would stay around for me. There is a flag you can flip in limited whip to make that happen, but I like the discipline I was trying to practice there. So with that, I'll encourage you to give things a try. And I'm hoping I might do another recording. There's another solution I have in mind for this same problem. Thanks for watching.